Hello, I'm Frank Sanders, Senior Technical Fellow at the Institute for Telecommunication Sciences, ITS, the Boulder, Colorado Laboratory of the National Telecommunications and Information Administration. I'm here to tell you about how the radio spectrum is occupied and used at U.S. National Science Foundation, U.S. Antarctic Program stations at McMurdo, Pole, and Palmer. The U.S. NSF utilizes an enormous number and variety of radio systems to sustain USAP's activities. These systems support safety of life, navigation for air and maritime operations, station logistics and maintenance, and scientific data collection. Without radio systems, the USAP would probably not be sustainable. Good radio spectrum use, including avoiding interference problems, begins with knowing what's in operation across the whole radio spectrum. This talk provides an overview of USAP radio systems for technicians and scientists so that they will know how their own work and systems do and will fit in with everybody else's radio systems. The information provided here should help you to understand how your own work and operations at and near these stations, with your own or someone else's radio systems, fits into the overall picture of radio spectrum operations in Antarctica. A second talk that follows this one describes how new radio systems are initiated and how existing systems are maintained, including how interference problems are addressed and resolved. In this talk, we will work our way across the USAP radio spectrum at frequencies ranging from below 1 MHz to as high as 300,000 MHz or 300 GHz, one band at a time. A note on terminology. Radio bands have allocations for the types of systems that can operate in them. The NTIA spectrum chart shows band allocations. But permission to radiate actual individual transmitters, equivalent to a license, is called an assignment. McMurdo has about 700 assignments. Pole has about 70 assignments, and Palmer has about a dozen assignments. In the second talk, we will discuss how to obtain USAP assignments. We begin with frequencies between a fraction of a megahertz to as high as 50 megahertz. This band is called high frequency, or HF, because frequencies like 50 megahertz were high in the early days of radio technology. HF radio waves have the useful property of propagating to long ranges along the ground, and also going into the sky and traveling through and bouncing off of our planet's charged ionosphere. Therefore, they are useful for communications that reach well beyond direct line of sight. In the USAP operations, higher frequency HF communications are used to talk to aircraft when they are hundreds and thousands of miles from stations such as McMurdo. Likewise, HF is used to communicate with ships at sea at the same kinds of distances. Portable HF radios and handsets are used to maintain contact with ground parties that are beyond line of sight to the station areas. HF is also part of the USAP scientific research. McMurdo Station and Pole Station each have an HF radar called SuperDARN for Super Dual Auroral Radar Network, part of a worldwide network. It probes physical phenomena such as ionospheric disturbances, remote ground and sea surface conditions, meteor ionization trails, and mesospheric ice crystals. SuperDARN uses selected frequencies between 8 to 20 MHz. We should mention here that most HF receiver systems at McMurdo are not located at the station proper. Rather, they are situated at Black Island, at 25 miles or 40 kilometers distance. That remote location reduces and prevents radio interference problems that can occur when radios are at or near the busy station area. Also, at the South Pole Station, there is an isolated area called the Dark Sector, so named because it is kept free of sources of potential radio interference that could degrade receive-only radio telescope operations. Moving above HF, there is an FM radio broadcast transmitter at McMurdo at 104.5 MHz. McMurdo's television is provided on a cable connection. The very high-frequency VHF band 108 to 136 MHz is used for air traffic operations, air traffic navigation, and aircraft landing systems. This band pairs with 225 to 325 MHz for aircraft communications and landing aids. VHF 138 to 157 MHz is used for land mobile radio communications. At McMurdo and Palmer stations only, VHF 156 to 162 MHz is used for line-of-sight maritime mobile communications, such as for communication with ships offshore and in port. 400 to 406 MHz is used for meteorological systems, such as dropsonde telemetry to weather satellite uplinks. At South Pole Station only, 406 to 470 MHz is used for some ultra-high frequency UHF land mobile radios. 960 to 1215 MHz is used for a variety of aircraft navigation systems. These transmitters may be associated with both the airfields and with some ships. The frequencies 1176 MHz, 1227.6 MHz, and 1575.42 MHz must be kept clear for Global Positioning Satellite System GPS functions. 1616 to 1626.5 MHz is used by the Iridium Mobile satellite for phone communications everywhere in the USAP at all stations, camps, and onboard aircraft and marine vessels. 1636.5 to 1645 MHz is used by the marine system INMARSAT. Radiosondes and other meteorological systems use 1668 to 1700 MHz. TeraScan direct readout satellite receive-only Earth stations at McMurdo Building 165 support image capture for weather forecasting at USAP stations. These TeraScan Earth stations operate at 1695 to 1710, 2200 to 2900, and 7750 to 7900 MHz. The Palmer Station Satellite Earth Station supports researcher and data communication operating at 3700 to 4200 MHz downlink and 5925 to 6925 MHz uplink. Antarctica NZ Satellite Earth Station supports Antarctic scientific research and operational activities, providing data communications operating at 3400 to 4200 MHz downlink and 5850 to 7075 MHz uplink. The NASA Near-Earth Networks direct-to-Earth ground station at McMurdo Station transmits at 2025 to 2120 MHz. It receives at 2200 to 2400 MHz and at 7700 to 8500 MHz. The 7700 to 8500 MHz reception band supports U.S. and European weather forecasting models for short to medium-range forecasts and are important for forecasting the ground tracks of hurricanes. The Defense Satellite Communications System, DSCS, DISCUS, at South Pole Station occupies 7900 to 8400 MHz. It facilitates communication and data links between the station and the USAP facility in Christchurch, New Zealand. The Tracking Data and Relay Satellite System, TDRS, at South Pole Station operates at 13.775 GHz downlink and 15.0034 GHz uplink. The NOAA Joint Polar Satellite System JPSS Office of Low Earth Orbit OLEO Earth Station at McMurdo Station is receive only, operating at 2200 to 2400 MHz and 25.5 to 27.0 GHz. This system supports U.S. and European weather forecasting. 2400 to 2483 MHz is occupied by unlicensed transmitters operating under FCC Part 15 and Part 18 rules. These include some wireless phones and microwave ovens. Microwave oven emissions from housing and mess areas are high-powered and receivable at long distances. Wireless internet is available at USAP stations. Wireless internet frequency bands used at the stations are 2400 to 2500 MHz, 5150 to 5250 MHz, and 5725 to 5875 MHz. At South Pole Station, indoor Wi-Fi links are active and available in the 2.4 GHz and 5 GHz bands year-round. In the austral summer only, outdoor 2.4 GHz Wi-Fi links are also active and available. In winter, outdoor Wi-Fi is removed and stored to reduce RF emissions as much as possible for dark sector science projects. There are no cell phone towers or base stations at USAP stations. Cell phones and other personal, unlicensed wireless devices can, however, operate on the wireless internet links already mentioned. Microwave links on individual frequencies between 7 to 24 GHz connect Black Island to McMurdo. Ross and Black Island also leverage microwave links at 24.05 GHz to 24.25 GHz to serve as a failover for Black Island monitor and control. McMurdo Station maintains a tracked vehicle with marine radar for search, rescue, and ice shelf transport between Ross and Black Island. The marine radar operates between 9300 to 9500 MHz for locating, navigating, and guiding home lost vehicles on the ice shelf during poor visibility conditions. A 9 GHz Doppler weather radar will soon be installed at McMurdo Station. Ross Island Earth Station provides primary satellite telecommunication services for McMurdo Station, operating at 10.007 to 12.20 GHz downlink and 14.0 to 14.8 GHz uplink. Starlink operates in the frequency range of 12.0 to 18.0 GHz for broadband satellite internet services. At South Pole Station, receiver-only radio telescopes operate year-round on frequencies between 30 GHz to 300 GHz. These include the South Pole Telescope at 80 to 110, 130 to 165, and 190 to 250 GHz, and the BICEP array telescopes at 25 to 35, 35 to 45, 80 to 110, 130 to 170, 190 to 250, and 250 to 295 GHz. Finally, we come to the visitors who can appear unannounced and unexpected. Tourists are allowed to visit McMurdo with prior planning and authorization, and in the austral summer, cruise ships can come within a few hundred yards of the shoreline. Some visitors disembark ashore to see old ruins at Hut Point. These ships and visitors may have an assortment of radio transmitting devices. At South Pole Station, all dark sector science buildings are off-limits to visitors. However, coordinated tourist overflights occur in the austral summer. Some NSF pre-coordinated adventure tourists ski through the area and camp near the USAP station while the sun is up. These visitors may have an array of radio devices. NSF encourages pre-coordination of RF device use, though this is voluntary. Pole radio astronomers are advocating for improved coordination with visiting groups to manage RF emission risks to their research. The Antarctic Treaty Parties designated the region around the South Pole as Antarctic Specially Managed Area, ASMA, number 5, to maximize the valuable scientific opportunities at the pole and ensure that all activities can be conducted without disruption to scientific programs. South Pole Station is very compact geographically, which poses special considerations for the coordination of radio transmissions and the protection of sensitive scientific research using the radio spectrum. The South Pole radio telescopes are designed with broad frequency coverage and are also susceptible to RF emissions outside their primary observation bands. Constant vigilance is required to detect and deter harmful emissions coming from general station and visitor activity, which is made more difficult by the proximity of all human activity at South Pole Station. Appendix D of the ASMA Management Plan provides guidelines to improve coordination between the national programs operating in the area and non-governmental visitors to the South Pole, and to inform visitors about on-site resources, expectations, and hazards. Appendix E provides maps of the area. We hope this introduction to USAP radio spectrum use will help you to better understand and make use of the radio spectrum in Antarctica. For the Institute for Telecommunication Sciences in Boulder, Colorado, I'm Frank Sanders.